Okay, so we're back talking about section 4.5. We've talked about the three different types of equations you might be asked to solve in this section in the previous video. And now we're down to the applications, some of the applications of these log and exponential equations. So look with me on this example. It says, how long does it take $1,500 to grow to $2,000 compounded continuously? We've seen this formula before in a previous section. We've used it to solve for the A value, for the P value, but never for R or T. So because we couldn't solve for the exponent until we got to this section where we learned those strategies. So now we can figure out the rate and we can figure out the time. We can solve for the exponents. So here's an example. We know the A value, we're growing over here to $2,000. We know the starting value, the P value, $1,500. Did I put a rate on here? You need to know that at 7%. Now you still need to know one more thing, at 7%. So that they can't leave out two unknowns. We can't figure out time as well as figure out rate. We have to only figure one unknown. Actually, in a later video, the last thing we're going to do in chapter 5 is you can have two unknowns, but it takes two equations to solve that. So we'll have a strategy for that, but so far, no, we've not done that. And we couldn't do it with just one equation. So anyway, you did need to know one more detail, 7%. So change that to a decimal, and then T is the unknown, T for time. That's what we're figuring out. How long is the question. So how do you solve this? Well, I don't think this came up in our previous videos, but before I try solving an exponential equation, you should simplify as much as possible with old algebra. Right here where that's a times, P is times E, then E is raised to that. So there's a little times there. So the first step I would do to simplify is divide out the 1,500 and get E raised to the rate times time equals, divide that on your calculator, or just leave it like that for now if you want. Sometimes I just like to cancel out the zeros and call it 20 over 15. You can do that. Or as a decimal, you can do that as well. So either way is fine. But it comes out to be 1.33 repeating, so I don't want to have a repeating decimal and having round off error. So I will just leave that intact. So once you've simplified that down a little bit, now we're back to where we were in an earlier video. We're trying to solve for the exponent. Unknown exponent means we have to take the logarithm of each side. So you can take the LOG or the LN logarithm, but if E is involved, LN and E play well together, I like to say. LN and E work well together. They're actually on your calculator. One is the second option of it. So they play well together, and we'll see why in just a minute. So I recommend taking the LN of each side, log, and then so we've got the LN of 20/15. On this side, the reason we took the log is so that exponent would come down as a multiplier. So it multiplies onto ln e. Now check this out, or if you remember, ln of e on your calculator, just know it's always 1. So anything times 1 is just gone. It's really not a factor for it. 0.07t times 1 is just 0.07t. So then to solve, you divide out by the 0.07. And then T equals. We want to type this in our calculator, so you all check this out as well. I'm going to type it in with you. It's always subject to mistake, so if you catch me in a mistake, please do send me a message and let me know so I fix this on my video. But I'm going to check this out with you. The log ln of 20/15 equals, and then divided by 0.07. I am coming out with 4.1-ish, 4.1, some other stuff, but let's call it 4.1 to the nearest tenth. So that would be how long it takes. Does that seem reasonable to you? For 1,500 to go to 2,000 at 7%, it takes about 4 years for that to happen. Got 4.1. So that's the kind of things we can answer now. We can solve for time now. Let me give you another. Okay, the next example, it says a question that's often asked is about doubling time. How long would it take that money to double? How long would it take your 1,500 to become 3,000? Doubling time is a nice idea. So the example I have here is we're going to take $500, Compounded continuously. So the word continuously means continuously. Let's see if I can get that right. Enough use. Continuously means use the PERC formula. That's the continuous compounding formula. So we're using that formula, and this time we're going to do 5%. So we're going to do that problem again. We're going to take $500 and make it become $1,000. How long does it take $500 to become $1,000, or double at 5%? What do you think? What do you think that would be? All right, so pause the video. Solve that equation, please. The first step to solving is dividing out what's multiplied there. So I always recommend simplifying first. Notice you get 2. 2 equals e to the RT. And what I want to tell you is if you're doubling something, whether it's $500 becoming $1,000, $600 becoming $1,200, $2 million becoming $4 million, any number, if you're trying to double it over here, first step when you divide, you should get 2. That should always reduce to 2 equals e to the RT. So just know that's naturally every time going to happen. So that's kind of a shortcut. If you see you have a doubling time problem, just go ahead and do 2 equals e to the RT. Then to solve that, we take the ln, the logarithm of each side, and we always do that when we have an unknown exponent that we want to bring down as a multiplier to make it solvable. And then every time ln of e is always 1, so we can kind of leave that out and just divide by that 0.05 or the rate. So even a shorter shortcut, you might be noticing kind of a redundancy in all of these problems. The half-life doubling problems, they're really kind of our easier problems. Once you do a few of them, it's the same pattern every time. If it's doubling, it's ln of 2. That's as you've seen here. You divide, it's always 2 if it's doubling time. Then you take the log on this side, so you're going to have the log. And we do the ln log because of the e. So you have ln of 2 if it's doubling, and then it's divided by the rate. So it's always ln of 2 if it's doubling, divided by the rate. If you were tripling, it'd wind up being ln of 3 divided by the rate. If you're half-lifing, it's ln of a half divided by the rate. So that's kind of a shortcut to get there, if that helps you. Okay, and what is that? You might be wondering. I told you we would be finding something kind of interesting for you. How long does it take money to double at 5%? That's a question you might want to know if you're in a savings account or in a 401k. So what do you think that is? ln of 2, and then divide that by 0.05. And so that's about 14 years, 13.86. So if you're getting an average rate of return, say you're looking at retirement somewhere out in the future and you're like, well, I've got this amount of money, I'd like to have double that. How long does it take that to happen? If you average a 5% growth, it'll take you about 14 years for your money to grow, to double. Now, if you get a little higher rate, let's divide it by, let's say 7%. What if we were doubling and we were averaging 7%? You know, all that depends on the market, but let's just see what happens. At 7%, this is at 5%, at 7%, when I divide ln of 2 divided by 0.07, it comes out to be about 10 years. So that's a better number, right? You want to say, like if you're thinking about retiring and you say only 10 more years out, my money would double if I can get a consistent rate of return at 7%. And then you can play around with the formula with different numbers. Maybe you want your money to triple, ln of 3 divided by a rate. And that's a real interesting formula that you may, kind of tuck away for even later use, after algebra class even, right? Okay, number 3. We can also solve for, what does this one ask? For the rate. Number 3 on the handout says find the interest rate. So I don't know if we've done that together in a video. To the nearest 100th of a percent, we want it to produce $2,000. We want to start with $1,500. And we want to compound it quarterly. So that's not the PERC formula. Quarterly means we're going to use the other formula. And we're going to leave it in there for 3.5 years. So we know all the players except the rate. So this is our other compound interest formula. You remember that. So this is the one that compounds if you know the increment of time. So knowing the increment of time is quarterly, that'll be 4 we put there. Time we know, 1,500 is the principal, and 2,000 is what we want it to grow to. So let's plug in all our players. And, oh, rate is unknown, leave it R. And then divide it by quarterly 4. You use that in both places. And then time is 3.5 years. So that's our equation. What I recommend you do is work backwards on this. You can't take it on straightforward because you can't do the parenthesis. If you can't do the parenthesis, you can't raise it to that power. So you're kind of stuck there. So we have to work our way backwards with our algebra. Start with dividing by 1,500. I'm going to cancel out 2 of the zeros and just call that 20/15 since it comes out to be that 1.3 repeating again that I'm avoiding. I don't want any round off error this early on. Here it cancels. I'm going to go ahead and say what is 4 times 3.5 so that I don't have that, you know, just to simplify it a little bit. And that equals 14. All right, so there's where I would be stuck with that problem now with kind of the forward steps that I would know. At that point, what if that were squared? We would square root. If it were cubed, we would cube root. So 14th power, we would 14th root. That's how we get rid of that. So we have to do the same thing here, 14th root. So we're going to take the 14th root of 20/15. So we can do that on our calculator. And that brings out the 1 plus r over 4. Then, let me get this out of the way. So then I would bring the 1 across, and I have the 14th root of 20/15 minus 1 equals r over 4. Then the last step, I would times by 4 to get that divided by 4. So then all this side gets times by 4. So this is what we need to get out of your calculator very carefully. So that's what we want to try to type in. Now, you don't have a direct 14th root on your calculator. You have a square root, maybe a cube root, but not a 14th root. But you can do any root with the X root. There's an X root button under Math. If you go into the Math option, let me see if I can show you that on my Calculate 84 app. So if we go to Math, it's got everything you need there. There's that cube root I mentioned. And then below that, it lets me do the nth root. It lets me do any root that you like. So I'm going to press enter on that. And then it brings up a box. I'm going to put 14 in the V and then the 20/15. So I type that 14 in the V. Then I touch into that box if I can and do 20 over 15. You'll all be doing the same. And then minus 1. And then I'm going to times equal that and then times all that by 4. If I would have thought I would type the 4 in first, but I forgot. So I got 0.083045-ish. Then know that that is the decimal answer of it, but I'm supposed to be finding a rate. A rate should have a percent on it. So I'm going to go to right, make it 8.3045. And then I think the directions, what did I ask you? Round to the nearest, it should tell you in your homework. Round to the nearest 100th of a percent. Hundreds places right there. So it'd be 8.30 since 4 won't round it up percent. So that's what percent it would take for 1,500 to grow to 2,000 in only 3.5 years if it's compounded quarterly. Let's see, do we have time for one more of those? I've got other examples, kind of similar. May have to wait till the next video, so I'll come back to that, and I hope this helps.